Ventilation systems bring air into and out of indoor spaces. They are designed to deliver air that is heated or cooled to a comfortable temperature, filter pollutants and particulates from the air, and adjust humidity for maximum comfort. These systems also remove stale air from those spaces and return it to the air handling system to be reconditioned and redistributed or exhausted to the outdoors. The system is made up of louvers, where the outside air comes into the system, filters that remove particulate pollutants from that air, coils that heat or cool the air, fans that push it out of the air handler, ducts that carry the air out into the building, vents that allow the air out of the ducts, return vents and ducts that carry the air back to the air handler, and exhaust fans that vent the stale air back to the outdoors. By keeping the air moving in the system and conditioning it, the system performs functions to keep the indoor air quality at proper levels for comfort and health. This includes filtering the incoming outdoor air, as well as the reconditioned air for particulate pollution, as outlined in the air quality standards set forth in local building codes. The Department of Labor's Occupational Safety and Health Administration, or OSHA, sets air quality standards that are deemed safe for people to work in each day. These include not only the particulate pollution levels, but carbon dioxide levels as well. The ventilation system meets these requirements by bringing in outdoor air to dilute the reconditioned air as it passes through the system. Ventilation also displaces air in damp spaces, making the air more comfortable and keeping humidity from building up in the conditioned space. This is an important step in preventing mold and mildew, which is both a maintenance issue and a health issue, as the mold that results from too much moisture in the air can cause health problems for building occupants by aggravating respiratory conditions like allergies and asthma. Because they work year-round, ventilation systems are a big source of energy used in commercial buildings, accounting for nearly 8% of a building's annual energy consumption. The classroom module will cover ventilation system efficiency in great detail, but let's look at some of the common ways to make your ventilation system more efficient. Energy recovery systems integrated into ventilation systems are used to capture waste energy. Exhaust is a necessary part of any typical building's operation, but removing conditioned air from the building requires energy for the conditioning of replacement air. Some of this energy requirement can be offset by an exchange of energy between incoming and outgoing air. Some systems allow heat transfer from one air stream to the other to precondition the outdoor air. For spaces where large numbers of people congregate, but don't stay in all day, like conference rooms or classrooms, significant savings can be achieved by using demand control ventilation. Typical ventilation systems have outdoor dampers open and bring in outdoor air during all the hours the building is normally occupied. The demand control system, on the other hand, is controlled by sensors in the space that detect occupancy through carbon dioxide levels. This information is sent to controllers that open and close outdoor dampers to bring in outdoor air when carbon dioxide levels get too high, and close off when concentrations return to acceptable levels. A ventilation system that's functioning at peak performance protects occupants' health and comfort while saving energy.